Discuss about the structure of electrical power system, generation, transmission, distribution, but our main concern is transmission system, primary transmission system, secondary transmission system, what is the voltage, and then how the power sector will be divided into in our Andhra Pradesh state as well as in our country also. In state, Genco for generation, Transco, AP Transco for transmission system, and distribution AP SPDCL, AP EPDCL. Coming to the country, northern region, eastern region, northeast region, southern region, western region. All grids are connected by December 31, 2000, December 13, 31, 2013. Before that, first northeast will be aligned, and then western will be aligned, and then lastly total grids, 5 grids are connected in a date of 31st December 2013. Right? Now go for the and syllabus is type of conductors: standard solid conductors, standard conductors. In standard conductors, again two types: homogeneous, composite. So homogeneous is nothing but only single conductor, but coming to the composite is nothing but two conductors. So ACSR conductor, that is mainly we are utilizing in nowadays aluminum strands, aluminum steel reinforced conductor, otherwise steel reinforced aluminum conductor. So in middle of the conductor, steel rod will be available, and outer surface aluminum strands are available. Generally, for example, 22 by 7 ACSR conductor. Please give me ACSR conductor. 22 by 7 is nothing but 22 strands are aluminum, only 7 strands are steel. Similarly, they are asking in reverse manner: 7 by 27, 7 by 22, as usual. So which strands are low is nothing but that strands belongs to steel. Which strands are more number, that may belongs to aluminum. So ACSR conductors, right? Steel reinforced aluminum conductor, otherwise aluminum conductor steel reinforced, whatever it may be. So and then bundle conductors. So bundle conductor is nothing but ACSR conductors, but two or more connected together and with a span of S meters. Because of that span, because of that distance, we have to reduce the corona loss. Right? Next, we have to discuss about the skin effect. When we are applying a alternating current to the conductor, the current is encircled with surface of the conductor only, not the center of the conductor. So whenever you are applying a DC supply to the conductor, so overall conductor will be expanded. That is nothing but uniformly distributed throughout the conductor. But coming to the AC, tendency of current concentrate near the surface of the conductor. So center, there is no center, only surface of the current will be concentrated near the surface of the conductor. So that concept is called skin effect. Yeah. What are the parameters? Frequency, diameter, right? Nature of the material. Diameter increases, skin effect increases. Frequency increases, skin effect increases. Like that, we have to discuss the skin effect and also proximity effect also, right? Now go for the main concept, that is the calculation of inductance. Calculation of inductance. Generally, we know that the definition of inductance, ratio of flux linkages to the current, already known in EC subject, electrical circuit subject. Inductance, capacitance, right? Inductance is nothing but is the ratio of flux linkages to the current. Otherwise, simply say that what is the original definition of inductance is nothing but in a conductor, the flux linkages is directly proportional to the current flowing through the conductor. Psi proportional to I, right? And psi is equal to psi proportional to I, psi is equal to Li. So L is equal to psi by I, psi by I. So units of inductance is Henry, right? Sometimes we can calculate it as L is equal to d psi by dt. Change in flux linkages to change in time. Now we have to determine voltage induced in a conductor, that is d psi by dt. So L into dA by d, E is equal to L into dA by d. Voltage across the inductor, VL is equal to L into dA by dt. Well known formula, right? So generally the inductance is defined as the ratio of flux linkages to the current, right? So Henry, unit is Henry, otherwise Weber turn per ampere. Flux linkages means flux unit is Weber. Linkages means the flux will be produced in the tons, number of tons. That's why Weber turn per ampere. Otherwise Henry, right? So these are two important stages. We have to determine the inductance in two different stages. First one is flux linkages for single conductor and also parallel conductor. In single conductor also, we have to determine internal flux linkages due to internal flux and external flux also, right? So here inductance of single isolated current carrying conductor. Generally offline classes, first we have to derive the flux linkages formula. After then we have to derive the inductance, but here I am deriving single time only, right? So first of all, transmission lines are composed parallel conductors. It can be infinite long distance. So transmission lines are, so these are connected in parallel, right? Pole to pole. You have to observe conductors are connected in parallel with a long distance. To determine the inductance of particular transmission line, first of all you have to develop how much flux linkages surrounded by the conductor, because whenever you are giving a AC supply alternating current to the conductor, they will develop its own flux linkages. So first of all you have to calculate that flux linkages. First of all you have to calculate that flux linkages. So for that one, flux linkages for a single current conductor, let us consider a long cylindrical conductor having radius small r and it carries current capital I ampere RMS. This current set up them magnetic flux linkages. You see this slide. So whenever you are giving the current to the conductor, they develop internal flux as well as external flux. So they develop internal flux as well as external flux. First of all, we have to calculate this internal flux and then external flux and then calculate inductance. Inductance is in the sense, inductance is the ratio of flux linkages to current. First we have to calculate internal flux and external flux, both are adding. Then divided by current is nothing but inductance, right? So that's why first of all we have to calculate the flux linkages according to internal flux and due to external flux also. First of all, we have to calculate the flux linkages in a current carrying conductor due to internal flux. So let us consider a long cylindrical conductor having the radius small r. This is the basic view. So small r radius, and it carries capital I current. Because of that current, magnetic flux forces will develop inside the conductor as well as outside the conductor. So first we have to calculate the inside, right? So whenever we have to develop the flux internally, then MMF will be developed, right? So the magnetic field, because of that MMF, magnetomotive force, magnetic field intensity will be developed. So the magnetic field intensity at a distance of a point small x, of a distance a point small x. So h is equal to hx equal to ix by 2 pi x. hx equal to ix by 2 pi x, taken as equation 1. 2 pi x hx equal to ix, then hx equal to ix by 2 pi x, taken as equation 1. Suppose I am assuming uniform current density. There is no internal flux, there is no external. Total conductor must be uniformly distributed. That is nothing but x equal to r, right? So some external flux will be there, some internal flux will be there, is nothing but x is different, r is different. Suppose, let us assume total flux will be distributed through the conductor. That is nothing but x equal to r, such that so ix is equal to pi x square by pi r square into I. That is nothing but pi x square, similarly pi r square. Circumference, circle pi r square, that is nothing but this one, and pi x square internal. So both are equal. So that's why ix is equal to x square, pi cancel, x square by r square. Ix is equal to x square by r square into I, taken as equation 2, right? Now substitute equation 2 into equation 1. Ix value, ix value is equal to the value of ix equal to x square by r square into I. Now substitute that ix value in equation 1. Now, so hx is equal to so ix by 2 pi r square ampere turns per meter, taken as equation 3. Now find out the magnetic flux density. So that is the intensity, magnetic field intensity, and we have to find out the magnetic flux density. What is the relation between flux density and intensity? Flux density is directly proportional to the intensity, that is B proportional to H. B is equal to mu H. So mu 0 mu r is in the sense per mu r relative permeability equal to 1 for air. That's why Bx is equal to mu 0 Hx, and we know that Hx value. So mu 0 I by 2 pi r square x, taken as equation 4, right? So now we know the intensity and we know the flux density. Now we have to find from that flux density, find out the change in flux d pi. From that we have to find out flux linkages. So first of all, you have to find out intensity. From that intensity, you have to find out flux density. From that, you have to find out change in flux d pi. From that, you have to find out flux linkages psi. Right? Here, mu 0 is the permeability of free space, and we know the value. Right? 4 into 10 power minus 7. So now let us consider a infinite to find out the change in flux. So this is the small one, change in flux d pi. I am taking d pi with a small distance dx. Let us consider the length of the conductor is 1 meter. Therefore, d pi x is equal to bx into dx into 1. And we know the bx value, mu 0 I by 2 pi r square x into dx, taken as equation 5. These flux linkages with current Ix only. So because of current Ix, this much of flux linkage will be developed in the inside of the conductor. So therefore, suppose on the assumption of uniform current density, so d psi is equal to x square by r. Why? Because d psi is equal to pi r square by pi x square by pi r square. So d psi and x square by r square, and d psi is nothing but that value mu 0 I by 2 pi r square x d psi dx. So now how to find out the flux linkages? We know the d psi. Some textbooks, students, some textbooks d psi will be developed d lambda. In some textbooks d psi. I am taken as d psi. We can also consider as d psi. So from that differential change in flux linkages, how to find out flux linkages? So d psi is available. Now I am find out psi or lambda. D lambda is available. How to find out lambda? To integrate that one. That's it. To integrate that equation 6 to find out flux linkages. So integrate the above equation with respect to r. Now this one mu 0 I by 2 pi r for 4. How can you mu 0? Generally mu 0 I x cube by 2 pi r for 4 dx. Now integrate mu 0 I by 2 pi r for 4 is the constant value. X cube x power 4 by 4, right? X power 4 by 4. 4 is constant, that is mu 0 I by 8 pi r for 4. Substitute that intervals. R power 4 minus 0. So r power 4 cancel. So remaining factor is mu 0 I by 8 pi Weber turns per meter, right? So this is termed as equation 7. This is the flux linkages occurring inside of the conductor, otherwise internal flux linkages. Suppose you have to substitute the mu naught value, 4 pi into 10 power minus 7 by 8 pi into I. So that is a 1 by 2 into 10 power minus 7 I Weber turn per meter. Don't bother, you remember only equation 7. Flux, internal flux developed in the inside the conductor is mu 0 I by 8 pi. That's it. Suppose to find out internal inductance is nothing but internal inductance is equal to internal flux linkages by current. So that is mu 0 I by 8 pi by I cancel. Mu 0 by 8 pi is the internal inductance occurring in the conductor. That is the constant value mu 0 by 8 pi. Right? Substitute mu 0 value 1 by 2 in 10 power minus 7 Henry per meter. Right? Just remember flux linkage, internal flux linkages mu 0 I by 8 pi. Internal inductance. So mu 0 by 8 pi, not I. Mu 0 by 8 pi. Right? So now go for the external flux linkages occurring in the external, not internal. So this is the conductor, right? This is the conductor. Just observe, this is the conductor with a radius of r, right? So for last we have discussed the internal flux. That's why r is radius of the conductor total. But here this is the conductor. Now flux will be external. You have to calculate the flux linkages external or outside of the conductor. So figure shows that point PQ at a distance of D1 and D2. So D1 is nothing but surface of the conductor, this one, and D2 is nothing but Q. This one D1 and this one D2. Since the magnetic flux lines are concentric circles around the conductor, so the flux between the P and Q is also a concentric cylindrical. Therefore, first of all, to calculate the inductance means to calculate the flux linkages. To calculate the flux linkages means to calculate the change in flux. Change in flux మనకు తెలిస్తే ఫ్లక్స్ లింకేజ్ తెలుసుకోవచ్చు. చేంజ్ ఇన్ ఫ్లక్స్ ఎలా తెలుస్తుంది? ఫ్లక్స్ డెన్సిటీ తెలిస్తే చేంజ్ ఇన్ ఫ్లక్స్ తెలుస్తుంది. ఫ్లక్స్ డెన్సిటీ తెలియాలంటే ఇంటెన్సిటీ. సో ఫ్రమ్ దట్ ఇంటెన్సిటీ నుంచి మనం రావాలి. సో ఫస్ట్ వీ హావ్ టు ఫైండ్ అవుట్ ఇంటెన్సిటీ ఫార్ములా.
then flux density formula, then change in flux linkages, then inductance. Just you have to remember these 5 steps. So derivation is very simple, otherwise complex. So the field intensity with a distance of x externally, hx is equal to I by 2 pi x. Whatever it may be, it is a concentric circles, 2 pi r. In place of r, x is there. So 2 pi x, hx is equal to I by 2 pi x. So taken as equation 10 or equation 1, whatever it may be. And from that, bx is equal to, so bx is equal to, so mu 0 I by 2 pi x. Why? Because b is equal to mu 0 h. So it is nothing but I by 2 pi x. So b is equal to mu 0 by I by 2 pi x, taken as equation 11 or equation 2. Otherwise, no problem. From that, you have to find out change in flux with a cylindrical cell of radial thickness taken as 1 meter length. That is nothing but axial length. Axial length is 1 meter. So d pi is equal to b into 1 into dx, right? As usual, same ditto. So before one, internal flux, external flux, a small difference will be available. So d psi is equal to, d pi x is equal to bx into dx into 1. Why? Because we have taken axial length 1 meter. So you know the bx value, mu 0 I by 2 pi x dx Weber per meter. But here, the flux linkages conductor in between P and Q, that is nothing but, so this is the change in flux. Now this is the flux linkages between P, Q. There is nothing, integrate the above equation 11. So with a limits of d1 and d2. So therefore, sometimes they taken r1 and r2. We have taken d1 and d2, whatever it may be. So otherwise, so d1 d2, not d1 and d2, we are taken from this small r to infinity also. Some of the students, they guess. So what is the condition for at infinity station? That is also external, right? At infinity stage also, out of the conductor, that is nothing but external. Suppose you have to take in d1 and d2, both are external. Otherwise, in some textbooks, small r to infinity, the limits are small r to infinity. So whatever it may be. So suppose you have taken d1 and d2, d2 by d1, but suppose you have to take in infinity. So integral r to infinity 1 by x dx, mu 0 I by 2 pi x dx, right? From that we have to determine the, so inductance. What is the external flux linkages? Mu 0 I by 2 pi, integral small r to infinity 1 by x dx. Otherwise d2 d1 అదేం తీసుకోవచ్చు, no problem. But మనం small r to infinity తీసుకుందాం. So internal flux linkages, mu 0 I by 8 pi, that is a constant value. But external flux linkages, it is not a constant because of up to infinity, mu 0 I by 2 pi, integral small r to infinity 1 by x dx. Now combine both flux linkages. Both flux linkages is nothing but internal flux linkages plus external flux linkages, mu 0 by 8 pi plus integral small r to infinity mu 0 I by 2 pi 1 by x dx. So from those two equations, common factor is mu 0 I by 2 pi. Flux linkages total equal to mu 0 I by 2 pi 1 by 4 plus integral small r to infinity 1 by x dx. This is the total flux linkages. From that, we have to determine the inductance also. So look at this PPT. Total flux linkages is equal to, that may be total flux in the conductor due to internal as well as external. Internal is nothing but mu 0 I by 2 pi. Right, I am taking values here, mu 0 I by 2 pi, whereas internal mu 0 I by 8 pi, external mu 0 I by 2 pi integral r to infinity 1 by x dx. So right, so now find out the total inductance, right? Inductance is nothing but 2 into 10 power, we have to substitute the values, mu 0 values, 2 into 10 power minus 7 I. What is, how can you find out this 2 into 10 power minus 7? So from this mu 0, so please concentrate, mu 0 I by 8 pi, mu 0 I by 2 pi into integral r to infinity, so 1 by x dx, right? Here mu 0 I by 2 pi, here mu 0 I by 2 pi, common factor. That is nothing but mu 0 I by 2 pi 1 by 4 plus 1 by 4 plus integral r to infinity 1 by x dx. What is the mu naught value? 4 pi into 10 power minus 7. So by 2 pi, 4 pi 2 pi. So 2. 2 into 10 power minus 7 into I. So this is the value. Do you understand? How can you get this value is nothing but mu 0 I by 2 pi. Mu naught value 4 pi into 10 power minus 7 divided by 2 pi. So 2 pi multiplied 2, that is nothing but 4 pi. 2 into 10 power minus 7 I, 1 by 4, 1 by 4, ln, you have to that value. Small r to infinity, but small r to capital D. So d by r, d by r dash, So 2 into 10 power minus 7 I. Suppose you have to take in logarithmic. This is the logarithmic value. This is not a logarithmic value. So 2 values getting logarithmic value 1 by 4, that is e power 1 by 4. So taking logarithmic of e power 1 by 4 is nothing but 1 by 4. There is no change. That's why first term also 1 by 4 is also in terms of logarithmic, and combine both. Combine both. So ln e power 1 by 4, right? Ln base e 1, that's why ln e power 1 by 4. Combine these two, log a plus log b, log a by b, right? So sorry, log b by a. So log d by r dash by e power 1 by 4. Now what about e power 1 by 4 value? So that is 0.7788. So the important value, what is the r dash value? 0.7788 r. So therefore inductance, so flux linkages, total flux linkages 2 into 10 power minus 7 I ln d by r dash Henry per meter. Therefore to find out inductance, inductance is nothing but flux linkages by current. So I cancel, remaining term is 2 into 10 power minus 7 ln d by r dash Henry per meter. So very important. The inductance of single phase is 2 into 10 power minus 7. So ln d by r dash Henry per meter. Sometimes in problems find out the inductance in millihenry per kilometer. Generally 2 into 10 power minus 7 ln d by r dash, right? R dash is nothing but 0.7788 R Henry per meter. Suppose they asking, find out the inductance in millihenry per kilometer. So many times they asking. So that's why, so 0.2 ln d by r dash millihenry per kilometer. 2 into 10 power minus 7, 10 power minus 3 below, 10 power minus 3 above. So 10 power minus 6 will be cancelled from the 10 power minus 7. Only 10 power minus 1 is available. That by, therefore 0.2 into log otherwise ln d by r dash millihenry per kilometer. Otherwise 2 into 10 power minus 7 ln d by r dash Henry per meter. So both are very, very important. So look at once again recap. So this is the flux linkages due to internal flux linkages in a conductor, and this is a external flux linkage in a conductor. From this, what is the flux linkages? Mu 0 I by 8 pi. From this, what is the flux linkages? So this one, mu 0 I by 2 pi ln d by r. So d1 plus r. So now external inductance and internal inductance, both are combined to each other. Here 2 pi is there, here 8 pi is there. You have to common mu 0 I by 2 pi is nothing but 1 by 4 plus ln, so ln d by r dash. That mu 0 I by 2 pi value is, mu 0 by 2 pi value is 2 into 10 power minus 7, right? So just recap, all these things will be recap. So inductance of a single phase two wire line, let us consider here. So single two conductors, between spacing is d and radius is r1 r2, like that. So flux linkages is 2 into 10 power minus 7 ln d by r dash. Inductance means I cancel 2 into 10 power minus 7 ln d by r dash. So outer conductor, similar manner. Suppose now two conductors will be there. For one conductor 2 into 10 power minus 7 ln d by r dash Henry per meter. For another conductor 2 into 10 power minus 7, so ln d by r dash Henry per meter. Now both conductors in a loop or a circuit, L is equal to L1 plus L2, that is 4 into 10 power minus 7 ln d by r1 r2, that is nothing but r square, that is nothing but r dash. So 4 into 10 power minus 7 ln d by r dash Henry per meter. Otherwise so 0.4 ln d by r dash millihenry per kilometer. Otherwise 0.921 log, not ln. Log is nothing but base 10. So but we did not consider this equation 6. We consider only this one, L equal to 2 into 10 power minus 7 ln d by r dash for single circuit, and suppose loop circuit 4 into 10 power minus 7 ln d by r dash Henry per meter. And this is the, so 2 into 10 by ln 1 by r dash. How can you get this one? So don't confuse, just you have to observe the derivations. First of all, you have to find out the intensity, then flux density, then change in flux linkages, then flux linkages, then inductance. So this is the, so derivation of inductance. Already we discussed, right? So same thing, total flux, internal flux, external flux. Inductance is nothing but II cancel, 2 into 10 power minus 7 ln d by r dash Henry per meter. Otherwise 0.2 ln d by r dash millihenry per kilometer. Suppose in a loop inductance So this single conductor L1, second conductor L2, total loop L1 plus L2. So that is the. So how to find out the problem? A single phase line has two parallel conductors. So single phase line has a two parallel conductor, 2 meters apart. The diameter of each conductor is 1.2 centimeter, right? Calculate the loop inductance per kilometer of the line. Calculate the loop inductance per kilometer line. So formula is this one, 4 into 10 power minus 7 ln d by r dash. They given 2 meter spacing, d is equal to 2 meters, and diameter small d equal to 1.2 centimeter. Now convert that one into meters. 1.2 into 10 power minus 2, right? But we don't want diameter, we want radius r. So r is equal to d by 2. 1.2 into 10 power minus 2 by 2. So that is 0.6 into 10 power minus 2. That is the r value. But we want r dash value here. R dash is equal to 0.7788. R dash is equal to 0.7788 r, right? So that is nothing but how to calculate that r dash value, and already they given d value, right? How to find out that one inductance value. Right? First of all, please note down the problem. The single phase transmission line has two parallel conductors with 2 meters apart. Diameter of each conductor is 1.2 centimeter. Calculate the loop inductance per kilometer length, right? So, right, first of all, spacing between the conductor, right? D is equal to 1.2 centimeter, and radius of the conductor, sorry, spacing of the conductor is small, d is equal to 2 meters, and the diameter d is equal to 1.2 centimeter, that is equal to, find out radius 1.2 by 2, 0.6, right? Now the loop inductance formula, 4 into 10 power minus 7 d by r dash. Otherwise write down the formula, ma. Loop inductance equal to 10 power minus 7 in bracket mu r plus 4 ln d by r, ln d by r, Henry per meter. So substitute that values, you are getting the 2.423 millihenry, right? And also another problem is also there. So spacing is, suppose you have to put spacing 3 meters, and radius is 1 centimeter. Please consider both are centimeters or both are meters. Suppose put both are centimeters. Here spacing capital D is 2 meters is nothing but 1 meter is 100 centimeters. Therefore 200 centimeters, and radius is 0.6 centimeter. Both are cancelled to each other. Otherwise, so this is meter, convert the centimeter into meter, otherwise whatever it may be. For simple foot centimeters, both are centimeters. 2 into 100, 200 centimeters, 0.6 centimeter. And formula is, in loop inductance per meter is 10 power minus 7 in bracket mu r plus 4 ln d by r. That is the formula. So you have to calculate that one also. This problem answer is 2.423, and you have to calculate 3 meters. Spacing is 3 meters. Radius is 1 centimeter. Radius is 1 centimeter, not diameter. We have to calculate that one also, right? Sometimes they are asking determine the loop inductance per copper and also steel. And determine the loop inductance for copper and steel. Here the mu value will be different for copper and steel. For mu value is 1 for copper, 100 for steel. That is the important problem. So most of the times they are asking this problem. Once you have to come into the college, I will explain once again also problem. So any doubt, please ask me. So this is the ACSR conductor. So below steel strands, above aluminum strands. So this is the most important formula. How many number of strands are the, how many number of strands will be available in a given ACSR conductor means n is equal to 3x square minus 3x plus 1. So x is nothing but number of layers. Most important formula to note down this formula, and it utilized for the competition exams, GATE and GENCO, TRANSCO, like that. N is equal to 3x square minus 3x plus 1. X is the number of layers. And overall diameter, what is the diameter of ACSR conductor is nothing but 2x minus 1 into d, where small d is the diameter of the strands. Right? So this is about flux linkage. Internal flux linkage occur in a conductor, external flux linkage occur in a conductor, and inductance value of single phase two wire system, right? And problem. So mainly they are asking this type of problem only. Determine the loop inductance. Determine the loop inductance. Sandhya,
Sir.
are you note down the problem?
Yes, sir.
So this problem, screening problem, I mean appearing problem, and also another problem also note down. A single phase transmission line has parallel conductors 3 meters apart. 3 meters apart. Full stop. A single phase transmission line has two parallel conductors 3 meters apart, comma. The radius of each conductor being 1 centimeter. The radius of each conductor being 1 centimeter. Full stop. Calculate the loop inductance per kilometer length of the line. Calculate the loop inductance per kilometer length of the line. Length of the line, comma, comma. If the material of the conductor is, first one copper, second one steel with relative permeability of 100, steel with relative permeability of 100. Once again, a single phase transmission line has two parallel conductors 3 meters apart. So the radius of each conductor being 1 centimeter. Calculate the loop inductance per kilometer length of the line. If the material of the conductor is, so first one copper, second one steel with relative permeability of 100, right? So note down the formula. loop inductance per meter equal to 10 power minus 7 in bracket mu r plus 4 ln d by r, ln d by r, not r dash, r. ln means logarithm base e amma. ln means base e, not base 10. So formula loop inductance equal to 10 power minus 7 in bracket mu r, relative permeability, plus 4 into ln d by r, Henry. Right? A problem with chain. So to do the problem, to put copper mu r equal to 1. First, spacing the conductor small d equal to 300 centimeter, then radius of the conductor small r equal to 1 centimeter. Now formula loop inductance is equal to 10 power minus 7 in bracket mu r plus 4 ln d by r Henry per meter. So first, with copper conductor siding, mu r equal to 1. Therefore, loop inductance per meter equal to 10 power minus 7 in bracket 1 plus 4 ln 300 by 1. So that is equal to 23.8 into 10 power minus 7 Henry. 23.8 into 10 power minus 7 Henry. So that is the loop inductance per meter. Next, loop inductance per kilometer. 23.8 into 10 power minus 7 into 1000. So that is 2.38 into 10 power minus 3 Henry. 2.38 into 10 power minus 3 Henry. Otherwise, 2.38 millihenry. 2.38 millihenry. Next, second siding with steel conductors mu r equal to 100. With steel conductor mu r equal to 100. Therefore, loop inductance per meter equal to 10 power minus 7 in bracket 100. Now mu r equal to, for steel, 100. 10 power minus 7 in bracket 100 plus 4 ln 300 by 1. 4 ln 300 by 1, that is equal to 122.8 into 10 power minus 7 Henry. 122.8 into 10 power minus 7 Henry. Now for kilometer. Next, loop inductance per kilometer. 122.8 into 10 power minus 7 multiplied by 1000. That is 12.28 into 10 power minus 3 Henry. 12.28 into 10 power minus 3 Henry. Otherwise, 12.28 millihenry. So 12.28 millihenry. So most important problem. So many times they are asking this problem only without changing values also. So now I am dictating problem, right? Answer is 2.38 millihenry. Another one for steel 12.28 millihenry, right? Are you note down? Sandhya? Hello?
Sir. Sir.
Are you note
చెప్పండి.
down the problem?
చేశాను సార్. నోట్ డౌన్ చేశాను సార్.
Okay. So you have to do the problem 1 also by using
Okay, sir.
that formula only, not using this formula. So loop inductance is equal to 10 power minus 7 in bracket mu r plus
Plus 4
4 into
log n.
ln d by r, not r dash. D by R, Henry per meter. Suppose they don't given any conductor name, put in place of mu r 1. Right? Suppose
Okay.
they given copper or steel, put given values. Okay. Thank you. So next class we discuss about the composite conductors. There is nothing but three-phase lines. First of all, you have to derive the flux linkages for three-phase, then inductance. Here, for single-phase only one derivation, but three-phase symmetrical spacing is there and unsymmetrical spacing there. Asymmetrical spacing is there. So you have to derive two equations and then problems. In that composite conductors, the concept of GMD and GMR will be coming. Right? Geometric mean distance, geometric mean radius. Thank you. Now I am stopping the presentation.